Dear ladies and gentlemen, I'm welcoming you all and thank you all for joining our tech talk regarding the topic DALI. This is our third event in English. All events can be found on our LOYTEC main YouTube channel. Today's tech talk is split up into 4 parts. In the first part, we will compare DALI 1 versus DALI 2 standard-wise. We'll see about the typical cabling and DALI power supplies. The second part is about the installation or commissioning procedure on our DALI compatible LOYTEC controllers and working with our integrated DALI analysis tools and informations regarding the DALI application on our L-DALI controllers. The third part is a live example on how to identify problems within the CLC application on our devices using the mentioned analysis tools of part 2. In the last part, we'll have a small discussion round where you will be able to ask some questions or even share some stories about your experiences with DALI. Part 1. DALI 1 versus DALI 2. Let us check the differences between DALI 1 and DALI 2. In DALI 1, only ballast could be more or less certified, as this certification process was a mere self-declaration by the manufacturer of the ballast, without external verification. Input devices, for example sensors or button models, were often using proprietary commands specified by the individual manufacturer. That meant that an input device may had to be implemented specifically. To have an overview of which DALI 1 device is compatible, LOYTEC keeps a DALI 1 compatibility list. All devices not mentioned on that list are not supported by our L-DALI controllers. In DALI 2, devices such as application controllers, bus power supplies, control gears, ballasts, or input devices are available for certification. The certification process includes the execution of a test algorithm published by the Digital Illumination Interface Alliance, abbreviated DIIA, for which the to-be certified DALI device must pass. If the test result was successful, then the device manufacturer is allowed to print the DALI 2 logo on the DALI device. Furthermore, the test result is published in the database of the DIIA. This database is accessible publicly under the following link. Since firmware version 7.4.0, our DALI-compatible controllers, for example L-DALI controllers, offer the possibility to directly view a DALI 2 device in the database. To view this, navigate to the DALI installation page and click on the I button of the device you wish to view. You then will see the Global Trade Item Number, abbreviated GTIN, as an hyperlink. Upon clicking on this number, you'll be redirected to the DALI 2 device's product page. Here you will find general information about the device, testing procedures, technical information, and which DALI 2 parts the device conforms to. Wiring and power supply. In this part, we'll take a look at the wiring of typical DALI installations. Please be aware that DALI is not SELV, safety extra low voltage, and must therefore be treated as mains. The two-wire DALI bus can be wired together with mains power. For this you could use a 5-wired installation cable. The max length of a DALI bus should not exceed 300 meters. In this table you will see the max DALI bus length when using the specified conductor size. This table is calculated through the restriction that the voltage drop shouldn't exceed 2 volts at 250 milliamperes. The DALI communication is based on short circuits. Due to this, a special DALI power supply must be used. Multiple DALI power supplies can be used, though the total supply of a DALI channel mustn't exceed 250 milliamperes. Otherwise, damages to the transceiver of the attached DALI device may be possible. Most of our DALI-compatible controllers offer an integrated DALI power supply. The max supplied power can be seen in this table. Under the following table you are able to see the typical usage of a DALI device on the bus. Please be aware that this usage must be multiplied with a factor of 1.2 for the times when there is no communication on the bus. This information is helpful when planning the dimension of the bus power supply. Part 2. DALI installation and commissioning, analysis tools on LOYTEC DALI controllers, information about the L-DALI application. How are DALI devices addressed? DALI controllers communicate to the devices via unique short addresses. In order to assign new devices, the controller must perform a DALI bus scan where the devices undergo an initialization process. During the scan, each DALI device generates a so-called random address, and this is repeated until each device is uniquely identifiable on the bus. Afterwards, when the device is being commissioned, it will be either assigned a new short address, if it doesn't have one, or our LOYTEC DALI controller will try to assign the device with its existing short address. The short address can be changed manually after the device has been commissioned. DALI short addresses are 6-bit long. This means they can be configured in a range from 0 to 63. In the following table, you'll see the limitations and address ranges of each device type on our L-DALI controller. Part 2. DALI installation and commissioning, analysis tools on LOYTEC DALI controllers, information about the L-DALI application. In addition to individually addressing a ballast, multiple ballasts can also be assigned to groups. The group assignment is saved on the ballast itself. Per DALI channel, up to 16 groups can be configured. Another special variety of addressing is accomplished with the usage of scenes. Every channel offers the possibility to configure up to 15 of these scenes. In a scene, each ballast can be assigned a different brightness and, if supported, also a different color value. Since firmware version 7.4.0, we offer the possibility to factory reset unassigned DALI devices. A reset of the whole DALI channel is therefore not needed anymore. The button can be found here under the unassigned devices. Another feature is to delete the short address. Along with these features come also two new search mechanisms. With partial scan, which do not have a short address assigned, will be search. Search for lost DALI devices will find LOYTEC devices which are in the bootloader mode. This may happen if a firmware update of the device was not successfully finished due to some reasons. Let us now check the DALI analysis tools which are available on our L-DALI controllers. On the web UI, under Statistics, DALI, you'll find relevant statistic counters for the DALI communication. Bus supply indicates the state of the DALI bus supply, also indicates status information of the power supply, displays internal when only the internal power supply for a controller is used to supply the bus, or external if either only an external power supply is used or a combination of both. Bandwidth utilization in a listed specific time frame indicates the amount of traffic on the bus. Bus supply failure and bus supply overload may indicate wiring problems or problems with the power supply on the DALI bus. Devices online indicates how many devices are online versus how many assigned DALI devices are offline. Mains on failed numbers at times mains power was not available. These DALI statistic counters are also thoroughly described in the LOYTEC Device User Manual Chapter 15.2.4. The DALI protocol communication, which includes the DALI channel-wide frames, for example, commands, requests, responses, can be displayed by clicking on Protocol Analyzer. We will investigate the DALI Protocol Analyzer later on. Another way to identify problems is by using the debug log. Under Configuration, Debug, you can find our debug log. First most, I'd always recommend setting the maximum size of the log. Clicking the Save button will store the configured setting. When changing the type to debug mask, you then have the possibility to activate the logging for certain type of events on selected types. The logging includes inputs, outputs, or the current state, and the type includes lamp actuator, group actuator, channel actuator, light sensor, occupancy sensor, constant light control, sunblind control, globals, and button. The selected types can be filtered to certain channel and or also to certain object indexes. Information about the DALI application, ballast parameters. Along with the short address, the group assignment, the scene configuration, DALI ballast store the following parameters: the max press value, which is the max dim level assigned to that ballast, the power on level, which is the dim level after power on of the ballast, means mains on, the system failure level in case when there is no DALI bus power available, fade time, ramp rate, and the minimum dim level of the ballast. The dim mode can also be configured here. Feedback values of a lamp actuator can be different from the writing data point, depending on where the dim level has been written from. A DALI command can either be written directly from a constant light control application, a button model, a data point button, or directly from the DPAL layer, that is in this case of lamp actuator, the data point lamp itself. You may have already noticed that written dim values may differ a little bit from the feedback value. This is because the dim level is counted in steps. Steps go from 1 to 254. The light output is calculated through the following equation. Here you'll find a table with some already calculated values. Part 3. Identifying problems within the CLC application using our analysis tools. For this example, we're having an CLC binding as seen here, and we're seeing that the occupancy sensor is reporting occupied, even though the light is still off, as seen here in the group level of 0%. In the data point overview of the constant light control instance, we can see that the CLC is properly configured. For example, the set point set to 3000 lux. The mode is also set, and auto mode should be active. The controlled variable value, which displays the current brightness level in the binary light sensor, is reporting the value of 17 lux. The calculated output of the CLC is also 100%, but the group is still off. What could the problem be? Values written over the network. We can try to identify this problem by using the DALI protocol analyzer and the debug log. The debug log is found under config, debug, and the size is already set as we did before. Let us navigate to the debug mask and add as a type the group actuator 10. This can be done by setting the channel to 1 and the object index to 0. We are now logging the group, which is controlled by our constant light controller application. Before saving the configured group configuration, activate the checkboxes for log inputs and log outputs. Now we will head to the DALI Protocol Analyzer, which is found under Statistics, DALI Protocol Analyzer. Make sure we're on the first channel, as our CLC application is running on this channel. Start the logging. Before we continue with the DALI Protocol Analyzer, let's make a quick detour on what kind of frames in DALI exist. The most common frame length in DALI is 8-bit, 16-bit, and 24-bit. 16-bit frames can either be requests or commands used for control gears, or also known as ballasts. 24-bit frames can also be requests or commands and are used to communicate with control devices, for example, sensors. 8-bit frames are answers to requests, for example, the request query actual level onto a ballast. Events are sent out by control devices to, for example, transmit occupancy. After waiting for a few minutes, we can see a command written from our L-DALI controller. The direction of a package can be seen here. We can also see that the command is written onto the group 100 with the level 0%. In the debug log, the situation looks as the following. We can see that the group is being written cyclically every minute. For example, here with this timestamp, then 1 minute before, and before, and before, and so on. Application side, the value can only have been written from our DPAL layer. How I came to this conclusion will be seen later on. The value therefore must have been written via the network, for example BACnet or OPC, or on the data point itself, for instance via the WebY, or also an local connection, or a math object. As the group data point itself is a commandable BACnet server object, it also implements a priority array. Our default configuration is using the write priority 8. This means all of these inputs are written to the mentioned priority. The default priority of the constant light controller is 16. This value can be configured directly while creating the CLC binding. Another problem with the CLC application could be that once in a while you can see that the property override is having a valid value. The override overrules the constant light controller application. The override can be triggered by multiple sources. Either the property override is directly written via BACnet on the loop object of the constant light controller instance itself, or via an input device, for example button model, is configured to write on the group or channel which is being controlled by the constant light controller. A scene is recalled on the DALI channel, or the DALI channel is being written by another DALI master, in this case application controller. Override via button model. Each button model input can be assigned a specific mode, function, and destination. The function, in this case available when the button mode is push button, can either be DALI commands, for example dim up, dim down, or also turn on or turn off, with the destination either being the channel or a group on any of the available channels of the controller. Then there are also application controlling functions. For example, auto to relinquish an override of a constant light controller instance, or also to set the occupancy of an area with the functions occupied or unoccupied. In order to find out if a push button is eventually triggering the override, we will add two types to our debug mask. We will use the type light control, which is the constant light controller, where we'll also set the channel and the correct index. As the second type, we will use the button. In this case, I will set the channel and the object index to all, as our DALI application allows to configure button destinations channel independent. As the time has now passed a little, we are seeing that push button 100 has been pressed, whereupon our L-DALI controller sends out a command to our group 100, which is the one being controlled by our constant light control application. The command in this case is up, which is a relative command to dim up the light level. Using the timestamps from the protocol analyzer, we can simply find the corresponding entries in the debug log. This would be here at 10:19:15, button 00 sends a long press event with the function 10. Thereupon we can see that our light controller 00 is displaying an override level of 2.31%. This is also obviously visible in the data point overview of the constant light controller. Another possibility how the override comes to be is by being written by another master. In our L-DALI protocol analyzer, it is possible to set different filters. The filter options are: do not show frames sent by other DALI masters, do not show frames sent by the L-DALI itself, show frames with error, or only show DALI dim commands, or DALI events. In this case, I'd recommend do not show frames sent by the L-DALI. You will still see the responses of the lamps itself, but the overview of the protocol analyzer should be much clearer since we do not see all the packets coming from our device. A frame sent by another DALI master or application controller looks like this. It is recognizable because of the direction and the frame type it has sent. So in this case, the group members are commanded to set the light level to 39.522%. The command can also be seen in our L-DALI debug log, but with no further information available rather than the feedback of the group. DALI commands coming from other masters cannot be traced to its source. Our last override possibility is the override via scenes. A scene command is written out directly on the DALI channel and can either be addressed to a certain group, this means only the addressed group members will restore the scene, but also can be sent as a broadcast on the channel. This means all ballast with an existing scene configuration, for example scene 0, will restore the scene. This is now the end of the presentation part. If you have any questions regarding our DALI controllers or DALI application, feel free to ask and we'll be happy to answer.
Hello.
Hello.
This is Roman. I have a question. Because
Hi.
In the last time I've seen some DALI ballast manufacturers for LED luminaires like Osram, for example. that they are identifying the drivers, the ballast, as a DALI 2 ballast. So we were looking in detail here in e-controls if this could be, if there could be any difference between a DALI and the DALI 2 ballast and or driver, and we did not see a difference on the standards. So I don't know if you can answer this.
Mm-hmm. I think that regarding the identification process, that actually nothing has changed. Norbert, maybe you can clarify if this is not entirely correct, but in my opinion, it should be the same DALI part regarding the control gear.
That's our opinion also, but it just only looks like some marketing issue to avoid problems in the market. Probably that someone says, okay, this is a DALI ballast, so, or a DALI driver, LED driver, so it will not work with a DALI 2 gateway like L-DALI, for example. So this should be probably our conclusion in order to make the customers understand that this is a DALI 2 driver, but in the end, it's the same as a DALI driver.
Yes, I mean, I think the point is here what DALI 2 is doing and what Hans showed at the beginning of the presentation. In DALI 2, you have the possibility to have a standardized test. I mean, for DALI 2, there is a test fixture and there is a number of tests that you need to execute with your ballasts. This is some timing issues. It tells you how fast you react after power on and all kind of timing parameters. And you need to fulfill this. And also one thing is that what Hans showed, there are these 8-bit and 16-bit commands. And in DALI 2, you can also have 24-bit commands, so longer commands.
Yeah.
And when you do these DALI 2 tests, then the test makes somehow sure that your device is able to handle all of that. And that is able to cope with these long frame commands, because what we have sometimes seen on some sites that there are ballasts out there with some buggy firmware that are somehow confused when on the same channel suddenly DALI 2 frames are upcoming. And sometimes when you have a certain content of the frame, they are getting confused and start acting in a strange way, or resetting or locking up or whatever. And basically for the DALI 1, everyone could say, I'm DALI certified, as I think, as long as you were a member at this DALI association or whatever. And as long as nobody proves that you are wrong, you can still claim this. It's similar to a CE mark. But with DALI 2, you're only allowed to have the DALI 2 logo when you pass this test, and you can look at it on the DIA website, what tests were performed and under what conditions they were performed. And so in that case, you have you can be sure that it passed these tests. And you are right that when you are DALI 1, or when you are only DALI, then this doesn't mean that this doesn't work on the DALI with a DALI 2 device, or that for sure there will be some issues, but there is the possibility that there are issues, because actually there are also more restrictive timing definitions in the DALI 2 standard than they were in the DALI 1 standard, actually.
Yeah.
So it's still true, but what you say doesn't mean that it does not work. But on the other hand, when you have a mixed setup between DALI 2 sensors and ballasts, then it's not a bad idea to have ballasts that are really DALI 2 certified, just to make sure.
Yeah, but the problem arises from one of our customers, which is a luminaire manufacturer, which in the actual situation of the components lacking. So he had some DALI drivers, but they were not really sure if they could sell it for an installation. I don't know. I don't remember exactly, but we told them that there was no difference from our point of view as a gateways manufacturer. So the L-DALI works exactly the same in the same way with the DALI driver or a DALI 2 driver when it comes to a white LED luminaire.
Yes. Actually, maybe I did understand you wrong. For the L-DALI, it doesn't matter. The L-DALI works with DALI 1 and DALI 2 ballasts the same way. So this is not a problem. Special handling for the standards only comes in when you talk about occupancy sensors and other kind of sensors. Then this was not standardized in DALI 1, but regarding ballasts for the L-DALI, it doesn't matter. But when you are combination between ballasts and sensors, DALI 2, then the ballast might be confused by the other sensors on the channel, not the L-DALI. For the L-DALI, it doesn't matter. But we have seen such sites actually, where this was an issue.
It is, yeah, okay. And second question, the PWM4 device for RGB whites. Let's say the hardware is exactly the same than the PMW4. It is. And the difference should be, I understand, it's only firmware. And in this case, the RGB white, it should be DT8, no?
You mean I didn't completely get the question.
Yeah, the question is if the we actually have on the catalog the devices, the PMW4 and PMW4 RGB white, no?
Yes.
On the website, we can see it, no?
Yeah, let me. The PMW.
Yeah, L-DALI PMW4.
Yeah.
L-DALI, well, it's still not on the website.
You mean the TC for the?
Yeah, there is. On the website is actually the L-DALI PWM4. Okay.
Yeah. Right. And then basically you see it when you maybe can I share my screen, or Thomas, you can go to the website or whatever. I mean, for the others, we are talking about the PW. That's a special LOYTEC module called PWM4. This is an LED driver module. Yeah. And there are different versions of that. There is one version, the PWM4, that has 4 LED outputs, and it can drive 4 normal LED stripes. Then there is one called PWM for RGBW, which is for RGB and white LEDs. So basically, you have one multicolor lamp with 4 channels, one for the white channel, and then for red, green, and blue. And then is one PWM4 TC. That's a one for tunable white LED stripes.
The question is the model, which is still not on the website, which is the RGB white. It should be DT8, no?
DT8.
Yeah, DALI.
I guess
the types of luminaires is DT1, DT2, DT3.
Honestly,
yes.
Yeah.
Yes,
Yeah.
DT8
Okay.
is a color control for lamps in the DALI standard. So
yeah, okay.
both the TC and RGBW version will be seen as DT8 device.
Okay. Okay. Perfect.
Thanks, Pierre.
Yeah, but in fact, just for you to know, we have a project with RGB white, and finally we bought the PWM4. We put the RGB white strip, and it works fine. It works really fine. But the only issue is that we have 4 DALI addresses, and that we have to combine both 4 addresses to get the correct color. Okay, so if you want pink, you have to choose some percentage of red and blue, for example. No.
Yeah. Sure. This is why you have the different models. I mean, you have the wrong model.
Yeah, but it works. So we made one installation, and it works really fine.
Yeah. But it's therefore we have the other ones. So the other ones, you will only see one DALI address, and then you have the the right DALI commands, of course. Yeah, right. That's why we have the different models. It's basically the same hardware, like you say, but the firmware is different, so it behaves differently on the DALI channel. Okay, yeah, the human-centric lighting. At the moment, we have not implemented this function because there are a lot of different ways how you want to implement this. One thing is you might want to follow the natural light, something like that. Another possibility is that some want to follow the biorhythm of the person, either the same way, or they want to have it in an anti-cyclic way, you know, to wake people up when they intend to get tired and stuff like that. So there are different specifications for that. And usually what we do is, in that case, on our DALI controllers, we have the possibility to implement scripting. And in that case, that's something where you basically can write any program code and implement any algorithm that you intend to use. That's at the moment our approach. Somewhere on the roadmap, I think there is a feature request to implement modules for that in a more flexible way and make it configurable. But as far as I remember, it's not yet scheduled for a certain release.
Okay, thank you very much.
You're welcome.
Can I ask a further question?
Sure.
So has on your DALI bus, is there short circuit protection onto that? So
on the DALI bus?
Yeah, if someone shorts that out, is there a possibility of damaging the controller? Or does it have a sequence that it will go through, you know, to protect itself if it sees a short circuit? So, for example, the lights will stay on at 100% whether it's open or short circuit. But is there a possibility on a short circuit that it can damage the power supply, the DALI power supply?
No,
I mean, okay.
Basically, the DALI, the straight answer to your question is there is a short circuit protection, and when you just make a short circuit on the DALI bus, then you cannot damage the power supply. The slightly longer answer is this has to be like that because the DALI communication is working in a way that you make a short circuit on the DALI channel. So basically you have your DALI, your constant DALI power supply, and when the controller or when the devices on the channel are communicating, then they make a short on this power supply. And that's the way how the communication works. Of course, in between the packets, there is a certain idle time, a certain period. Of course, this is then also used to load up the capacitors and everything, the power supplies for the bus power devices. Normally, I mean, it's normal that you have a short circuit there. But there is a short circuit protection for the DALI power supply that it's not getting damaged, but it will shut off the power when it detects that there is a short circuit. And in that case, you will see a mains power failure. I'm not sure if it's a mains power failure or if it's a channel overload actually. But at the end, I guess that the ballast will detect a DALI bus failure and will go to the bus failure level.
Yeah. So if it sees a prolonged short circuit, it then will protect itself.
Yes. Yes.
Yeah. Okay, and see whenever you're creating then your short address count, which may be from 0 to 63 or 0 to 64. Will your software inform you if the bus is overloaded once you go over the count of 63 or 64? Will it inform you that there's too many devices on the bus?
Hans, do you want?
I mean, so basically you actually cannot assign more than 64, for example, lamp actuators. So that's the one point, and the other point is on the WebY, you can actually see the amount of the assigned devices, how much current they're currently using on the channel. So you have basically an overview on that. And also, if you have some issues with the power supply, you will see it in the web.
I understand.
Or is overloaded. And
I'm mainly in the field, and I can tell you that a lot of the time that the bus will be overloaded by the contractor. They will try to put more fittings onto the DALI line than is recommended. So normally what some other manufacturers, as we pull in the short addresses, and once we get up to 63 or 64, it will stop and inform you that you have too many devices on the network.
Yeah, I mean, basically you need to distinguish between two things. You have one physical limit because every device on the channel requires some power. For instance, a ballast typically requires 2 milliamps, so it's not too much. But when you have some kind of sensors, then depending on the sensors, this can be way more. So it could be that your channel load exceeds the limit of the power supply with less than 64 devices or less than 64 ballasts or whatever. Also depends on the power supply. And the second thing is, in that case, you would need to add a second power supply or a stronger one or whatever. But a power supply there must never be more than 250 milliamps power supply on the channel. That's the maximum the ballast and the devices can withstand. But the second thing then is how many logical addresses you have available. So how many lamps you can address. That's a logical thing, how many short addresses you can assign. And here the limit is 64. So when you put more ballasts on the channel, you will have two issues. Either you're running out of power, then you will get a power failure, DALI supply power failure, or when you scan the bus, you will find less devices that are on the channel because you can just not assign more than 64. So these are two different things, but in any case, you cannot use, you can use a maximum of 64, maybe less depending on the power supply and on the devices that you have.
Yeah. I understand that. It's just, I know from experience that some contractors have actually put more devices than has been specified.
Yeah.
But another question is, for example, if you have, so you've got 300 meters at 1.5 with a 250 milliamp power supply. So if I was, what I'm wondering is, could I use one of your DALI power supplies as a repeater if I had a longer run than 300 meters? Is that possible? But it would also introduce two power supplies on the same DALI subnet.
As a repeater.
You see a maximum of 2 volts.
Yeah.
Volt drop on your run. So I'm just thinking, if it was a long run, is there a way of putting a second power supply on as a repeater?
I mean, the point is, it's not. No, this doesn't work. It's because this is not really a repeater. The DALI power supply is only supplying power, so it's not doing anything with the signal. The ballast and the controller is making a short on the channel, and this is what it is. I mean, it's the power supply only puts in the power. When you have a longer channel, actually there are DALI repeaters out there, so they would be on the channel and they would really refresh the signal, and you would have a galvanically separate the channel. So yeah. Then you would really need a DALI repeater, but you cannot do this with a power supply.
Yeah. So it would be recommended then to contact your technical support with the information of a line repeater.
Yeah.
To make sure that it's compatible with LOYTEC.
Yeah. I'm not sure what tests we did, because I mean, we are not offering such repeaters. I remember that there were some projects out there. I think Helva is producing such a repeater, what I remember. Yeah. And we had projects out there where this was used, but for us, it's very hard to say if it will work or not, because when you have such big networks, then it heavily depends on the physics on the channel, how many devices are installed, what kind of devices are installed, do you have any interference and stuff like that. So that's more a kind of trial and error, you know. It's hard for us to say for sure.
No, I'm just been asking you some tricky questions.
No, it's okay.
I apologize for that. Thank you very much, and I'll let someone else maybe ask some questions.
No, you're welcome. Thank you.
Okay, so if there are any further questions, then I mean, if Gary, if you have any further technical support, and we'll be happy to answer you. And yeah, otherwise, then we will end this meeting. I hope you learned something, and hope to see you guys again soon.
Thank you.